That's all you would do, okay? And they're paying attention to it, but they adapt. And we do not have to continuously be aware. Do we have to continuously be aware of the amount of light, of the smells that are around us? These sensations adapt so that we don't have to stay in constant exposure and picking up on that information. So what we're going to find with these receptors, we have receptors that are phasic. They operate in phases, meaning you get this huge burst of activity, like that light that I just walked into. I got that huge burst, all right? But if I were to continuously stand over there, even though it would be a little bit painful for me, I would adapt, okay? So they stop signaling. And then tonic receptors, rather than working in phases, they will just slowly adapt, give us the signals that we need. For example, proprioceptors. All the proprioceptors that are found, for example, in the joints of my body right now are sending information continuously so that I can remain upright. Pain. When you're in pain, that signal is pretty much continuous. It can intensify. It can be really heavy at first, ease off a little bit, but it's going to be one that's continuous until you do something to ease the pain. So we can either have something happen, boom, real quick, body adjust, or we can have something that's just slowly paying attention and keeping you aware of it. So the types of receptors that we have, this is throughout the entire body, okay? They're classified into either being based on their modality, their origin, or where they are found. If it's by modality, they can be a thermoreceptor. What do you think that picks up?
Hot and cold.
Hot and cold. Photoreceptor.
Light.
Light. Nociceptors.
Does that smell?
Ever heard of those? Pain. Nociceptors are for pain. Viscera don't have them, and neither does the brain. Chemoreceptors. Chemicals. Okay? Mechanoreceptors. Something mechanical, like those proprioceptors. Okay? How about origin? Proprioceptors, for example, they're picking up on movements of my body and helping me to stay upright. They're picking up on information to keep you upright in your chairs. All right? Interoceptors. Enter.
Where you?
Inside the body. Exteroceptors. External. Like for the skin. Distribution in the body. General senses. Under general senses, we would find mechanoreceptors. We would look at those proprioceptors. We would have exteroceptors. Special senses. Well, thermo could also be part of general, but photo, chemo, entero. So they're pretty much classified based upon where they might be found, the origin, what do they do. The receptors now, and once again, your textbook goes into great detail about the general senses, which I feel like just don't even need to be there, but just to give a quick overview of what they're trying to let you know in your textbook, about receptors for general senses. All of this out here, okay? They're relatively simple. The general sensations that you receive, the receptors pretty much are not technically specialized. They're specialized, but they're not special, okay? So, they can either be termed encapsulated or not. If they're not, this could be something like a free nerve ending. For example, picking up on warm, cold, some pain. They can be tactile. Note, these ones are tonic, meaning they kind of, stay on and keep going, all right? For example, light touch, texture, which is kind of cool, hair receptors. Not just hair of the head, okay? Got hair, other parts of the body. If they have a capsule, this means they're usually wrapped in accessory cells, ones that help the neuron, the glial cells, or connective tissue. A tactile corpuscle, which would only give a burst of information. For example, light touch. If they are an end bulb, okay, note where they're found. Mucous membranes of our lips and tongue. That's it. If they're bulbous, okay, something for heavy touch, pressure, stretching, that sort of thing. And then lamellar, once again, a huge burst. They're going to be in stuff like periosteum of the bones, joint capsules, a little bit of viscera, but stuff for like picking up vibration, movement. Pretty not dealing with only one type of energy, okay? Whenever we have these sensations occur, do you guys remember pathways? For example, we have the ascending, descending that we've talked about up to this point, okay? With the autonomic nervous system, we had the spinal routes, splenic nerves. Then information had to go by way of like first order neuron, second order. It had to go to the thalamus, where it was the relay station, to send it to the area of the brain it needs to go to, i.e. a little bit of review here for the test. Okay, so everybody remember that? Okay. And remember what we have learned up to this point. That term soma tells us what? Body. Okay? So our projection pathways, all right, if we are looking at the general senses, a lot of it dealing with the body, soma is being given here, okay? And don't forget, because this is good review for the test, you have sensory information that has to go in. Does everybody remember that? All right, and we have what kind of information have to come out? Motor, okay? So, do you guys remember how we had a receptor that made its way to an area of the cerebral cortex? It worked by way of that pathway. I think we talked about first, second, third order neurons, okay? So that by the time we got to the thalamus, we could make the way to the area of the cortex it needed to go to. So, okay, good review here. Good review, okay? Now, what we're going to see for the special senses, information will travel by cranial nerves. Very little of what we've talked about to this point went by way of a cranial nerve. Do you happen to remember up to this point what may have traveled by way of a cranial nerve? Do you guys remember?
Viscera.
Viscera,
Vagus
the
nerve.
vagus nerve. Okay, so up to this point, that's what we know. We know that that cranial nerve, the vagus nerve, okay, that one has dealt with my autonomic nervous system. So now I've got these other cranial nerves that are going to be present. They're going to be very, very active in the special senses. Okay, so one we didn't really talk about yet that is a sensation, okay, and we saw that represented in lab, okay, because luckily JP put the elbow in there for us, all right, and he told us pain began to travel here a little bit into these fingers. Pain, yes, it's necessary. Why is pain necessary?
Survival.
Survival, yeah.
As you see your last slide, it's your body's way of letting you know that something's not right.
It's letting us know something's not right, that we need to keep that species alive for survival. But for the most part now, when we have something hurt, what do?
Go back or stop it.
We want to stop it, and then a lot of times we try to mask it. Okay? Take a pill. All right? Sometimes that's not always the best option. Fighting inflammation, yes, is very good. Okay? But just because something might hurt doesn't mean you should take that pill to try to mask it, because what you'll end up doing if you forget that there's some pain there, which means some type of injury, okay, chances are you're going to continue to re-injure it. All right, so a lot of pain, I'm not a fan of them. All right, people are amazed, for example, like when I had both my hand surgeries, they're like, well, how many of your pain pills did you take? I didn't even get the prescription filled. I'm like, I didn't want it. I'll tell the doctor. I don't want it. Keep it. Tear it up. Tear the prescription up. And he's like, what? And I had to have my dog scratch the cornea of my eye, and I ended up having to have emergency laser eye surgery back in November. And you would think, okay, that's not going to be too bad. All right. Anybody in here ever had laser eye surgery? Okay, they had to like laser off the whole top of my cornea, okay? That hurt worse than a lot of things that I've ever had done. Even my knee surgery that I had, I was like, that hurt worse than that. And they were like, well, how many of your pain pills did you take? What? Can't believe that was all, I'm like, no, I didn't even want to take that one, but I kind of didn't have much of a choice. Because I believe that the pain is necessary so that I can help the area heal that has been damaged, okay? So, what we're going to find, nociceptors, they're very dense in certain areas of our body. We don't find these receptors on the brain. I think I said organs, I meant the liver. And first thing that happens is when something goes wrong and that tissue is now damaged, we get that first part of the pain, like the paper cut, for example. Ugh, okay? Well, then we can move into the dull ache, but what becomes important is for the body to actually pick up on the pain. We acknowledge the pain so that we can affect the issue. Does that make sense? okay, address it, so to speak.